welcome to Math Minds video. Unit 6 continued. We're going to review a concept that we've already saw a video on. Okay, this theorem says if three or more parallel lines are cut off by congruent segments of one transversal, then they cut off congruent segments of every transversal. So let's see what we have here. We have parallel lines. Okay, and we definitely in green see a transversal with congruent segments. So that means every time we draw a line, there are congruent segments on that transversal. So BD is 6, which means DF is also 6. Okay. So the second part of that theorem says, because we have if, so we need a then. And here it goes. And just like we said, BD is congruent to DF. All right, here we go. Let's put it into action. Got a lot going on in this picture. But what we need to focus on is we need to focus on parallel lines. We need to focus on congruent segments. And we need to focus on transversals. Well, I see my parallel lines here, here, and here, and here. But I don't see my congruent segments. So I'm going to have to write something up in this. And I am going to write that segment SR is congruent to segment RS, which is congruent to segment QP. So I have my congruent parts. Let me go ahead and mark that. Okay. So now the theorem states that if I have parallel lines and they're sectioned off by congruent segments, that when I look at other transversals, then all the segments on that transversal should be congruent. So let's take a look and see, take a look at this transversal right here. So if I know from here to here is 3, then from here to here is also 3, and from here to here is also 3, because all of those parts are on that transversal. Now we haven't even looked at the question first. Well, we're analyzing our diagram, okay, because we are thinkers, we are problem solvers. So from here to here is 2.25, and from here to here is 2.25, and the distance from here to here is also 2.25, because we are only concentrating at this time on one transversal. And the transversal that we're concentrating on is this transversal right here. So all the segments are 2.25. So we should be able to answer the question. All right. So we look at the question. The first one says, find the length of ZU. Anytime we see ZU and there's no bar, the answer should be a number. So let's go to Z. And here's U. Which transversal is it on? It's on the transversal. It's sectioned it off in units of 3. So from Z to U is 3. Let's check out T to U. Oh my goodness, they want to stretch it. So if I go to T to X, that's 3, and X to Z is 3, and then Z to U is 3. So T to U is 3 plus 3 plus 3, which is that. Try the last two on your own and push pause at this time. Here you go. Hopefully you got 2.25 and 4.5. All right, we're moving into 6.7, polygons in the coordinate plane. And what in the world is a coordinate plane? Can somebody tell? I thought I heard somebody say it is the XY plane. X-axis and the Y-axis, and it makes a coordinate plane. Which means, folks, that we're going to need an X and a Y to be able to find all locations. Well, we kick it off with some formulas that's going to help us since we're in the coordinate plane. We need a distance formula. We need the midpoint formula. And we definitely need the slope formula. So, folks, let's see what we need or what we can use the distance formula for. What can we use it for? Oh, it can help us to determine whether sides are congruent and whether the diagonals are congruent. So it can be very helpful. All right, we'll use the midpoint formula to determine the midpoint of a side. That can be helpful because if we find the midpoint, we can see if the sections are congruent when we connect those. We could check to see whether the diagonals actually bisect each other. And last but not least, the slope formula, which could be helpful to determine if opposite sides are parallel, to determine if the diagonals are perpendicular, and if the sides are perpendicular. Perpendicular, perpendicular, what is that? There's a number associated with that. You guessed it, it's 90 degrees. Okay? Push pause whenever you need to copy down the formulas and why we need to use these formulas. And this time we're going to practice on our graphing skills. We're going to do some prerequisite skills before we move into this. We're in the section on quadrilaterals, which are four-sided figures, but I'm going to ask you to classify a triangle. At this time, I would like for you to grab a piece of graph paper, and I would like for you to graph and label triangle A, B, and C. Push pause while you do that. All right, if this is done correctly, then you will see your triangle should look like this triangle that is right here. Now, it's asking us, remember our problem-solving skills, what's given, what is the question asking? The question is asking us to classify this according to the sides. Oh my goodness, what do we need to do if we want information about the sides? You guessed it. If we want to determine if the sides are congruent, we are going to have to use the distance formula. Yay. So what we do, folks, is we need to know the distance from A to B. We also need to know the distance from B to C. As well, we need the distance from A to C. It told us we need to use the distance formula. I am only going to find AB and allow you to find BC and AC. So be patient as I walk you through AB. All right, so the first thing I want to do is I write down my distance formula. The next thing I'm going to do is I'm going to plug in the values for A and B. So I plug in my A and B, and the next thing I do is I simplify what's in parentheses. After I simplify what's in parentheses, I square the terms. I get the distance is equal to the square root of 16 plus 9. This becomes the distance is equal to the square root of 25, which is plus or minus 5. But since we're dealing with distance, only the 5 works. There's no such thing as a negative distance. So I come over here and write on my triangle that AB is 5 units. Then it's your turn to do BC and AC and compare your answers to mine. Pause at this time, use the distance formula to find the distance from B to C as well as A to C. Okay, you should have gotten that BC is 5, AC was the square root of 50, or 5 square roots of 2, or if you want to change it into a decimal. So what we're going to do is we're going to put this information on our picture. 5 and the square root of 50. What I notice is two sides are congruent. Which one of these vocabulary words represent two sides congruent? You got it, isosceles. Therefore, triangle A, BC is isosceles. Okay, this is just a little something to kind of help us classify a parallelogram. We know there are other quadrilaterals, but let's just work with the parallelograms. Now, we're going to talk about sides. When we think about sides of a rectangle, only the opposite sides are congruent. So if you use the distance formula, you find out that one pair side is 5 and the other pair is a different number, then you may want to consider that the figure could be a rectangle. All right, let's look at a rhombus, which is another parallelogram. It says that all sides are congruent. All sides are congruent. Ooh. Well, the shape I just made sure doesn't look like all sides are congruent, so let's try something else. All sides are congruent. That means if this side is 6, this is 6, this is 6, and this is 6. That's helpful because when we use the distance formula, we should be able to determine it or narrow it down to maybe a rhombus or a square. All righty. Let's look at a square. A square, again, all sides are congruent as well. There's other information I can tell you about the angles, but just want to give you a little taste of how to classify these. All right, now let's talk about the diagonals of each one, because we know that the diagonals extend across the figure. Well, technical difficulties. Well, here it says with the diagonals, if both diagonals are congruent, it could possibly be a rectangle. But what does that mean? That means if this diagonal here is 10 units, then this diagonal going this way is also 10 units, okay? Or if we wanted to say the whole thing was 20, we could say 10, 10, 10, and 10. All right, so rectangles, let's just know that both the diagonals are congruent. I'm going to skip down here to square, because in the square it is also saying that the diagonals are congruent. So if I say this is 4, and this is 4, and this is 4, and this is 4, and the diagonal here is 8, and this diagonal also is 8. So we know that with the rectangle and the square, the diagonals are congruent. All right, the question is, what about this rhombus? The vocabulary has changed. It says that the rhombus, the diagonals bisect each other. Now, wait a minute. Diagonals bisect. How is it different from being congruent? Well, let's take a look at the rhombus. Well, in the rhombus here, all sides are congruent. Don't go by the picture, go by the markings. This diagonal here may be 7. Well, not 7, let's go with 8. So that means this is 4 and this is 4. But if I wanted to do B and D, and it is only 2 from here to here and 2 from here to here, if I rewrote this figure, this diagonal would be 8 and this diagonal would be 4. So they bisect each other, which means the 4 is definitely congruent to the 4. And at the same time, if I were to erase this, I could write 2 and 2. So I get it now. Diagonals bisecting mean the sections are congruent, and the diagonals congruent mean they all have the same number. So I got that, okay? So these are just little nuggets and tidbits to help you to distinguish between giving a precise name for. Something else you want to take a special note of, diagonals are perpendicular. Perpendicular, this is the symbol, and this is the degree. To check to see if the product of the slope is equal to -1. You want to know if it's perpendicular, check to see if you multiply, will the product come out to -1? So here we go. If m is equal to 3, and m sub 1 is equal to -1 over 3, the question is, are they perpendicular? Let's check. We're going to take the product of the first slope times the second slope, that's what product is, and we're going to say 3, which we got from this slope, times -1/3, which is my other slope. Let's multiply together and see what we get. Oh, they multiply to -1. So guess what? These two lines are perpendicular. Keep that in mind because you may have to check for perpendicular 90-degree angles or 90-degree angles at a diagonal for they bisect. All right, folks, this one is for you. Here's the picture. I'll need you to jot down the points. I want you to use the distance formula. I want you to use any formulas you can, but you need to classify, give me a name, and explain your reason. Okay, there are several ways to do this. I mean, some people are going to use slope, some will use distance. Well, so you can rest assured that however you did it may not be the wrong way. But I'm going to show you this way. I'm going to connect A to B, and I'm going to connect D to C. And I'm going to see what the slope is of these two. Well, slope is rise over run, and you definitely have the formula, and you can plug in the points. But in order to get from A to B, I must rise 1, 2, 3. So my rise is 3. And I run over 1, 2, 3, 4. So the slope of this is 3/4. I do the same thing with D, 1, 2, 3, 1, 2, 3, 4. And so my slope is 3/4. Now I want to check the slope from A to D. I'm trying to see if it's at least a parallelogram. So to go from A to D, or excuse me, from D to A, it doesn't matter, as long as I put the corresponding numbers with rise and run. I go 1, 2, 3, and I go over 1, 2, 3, 4. Let me check from C to B. 1, 2, 3, and over 1, 2, 3, 4, 5. Okay, technical difficulties. I see where I went over too far. Because when I did the other slope, I did 1, 2, 3, 1, 2, 3, 4, up, 1, 2, 3. So C is actually right there. So I'm going to erase this line. Sorry about that. And make it purdy. All right, and so I go over. Did I go over right? All right, I think I may have it now. Let's see. I should start at the right location with help. 1, 2, 3, and over 4. So I'm going to scratch this and put 4. This is 3, 4. Okay, so guess what? I can go ahead and put in my lines that these are parallelograms. Now the question is, parallelogram, it still could be a rhombus, a kite, excuse me, not a kite, a rhombus, a rectangle, or a square. So I definitely need to check the distances, or I could check the diagonals. Let's check the distances and see what the distance is. All right, after doing the distance formula on each one, I find out that each one of these is 5 units. So I've narrowed it down to a parallelogram. I've narrowed it down to a rhombus or a square. Oh my goodness. Now how am I going to figure out if it's a rhombus or a square? Well, we said that the difference between a rhombus and a square was that the diagonals are congruent in a square and they bisect in a rhombus. So I tell you what, let's find the distance of AC and let's find the distance of BD and compare. So I tell you what, at this time I want you to use those points, and I want you to find the distance from A to C using the distance formula. And I want you to find the distance from B to D using the distance formula, and let's see what you come up with. Matter of fact, once you get that, I'd like for you to put it on a separate sheet of paper with your name, and definitely submit that so that I can see your work and see what you got, and I need you to classify it. Last but not, I want you to copy down these problems on a little small sheet of graph paper. I want you to graph these, and I want you to determine if it's a rhombus, a rectangle, or a square. And maybe it's none, but whatever it is, I need you to explain. Sorry for the long video.